Hello, this is my presentation for the Mobile Development CA, which is an Android app written in Kotlin and designed to the MVVM architecture. To begin with, I'll explain the code step by step, not in too much detail but given a bird's eye view of how it works, and I'll highlight anything that I consider to be an extra feature. Following that, I'll demonstrate the functionality of the app, which has two separate branches. The second branch has one additional feature that sort of works, but I haven't merged it with the main branch in case it broke the fully working version. So to get into the code explanation, we begin in our main activity, and it's in our main activity that we tell Android to use our activity main layout file, and we define which files to use for our nav controller and our nav host fragment. So here's our activity main, and in here in turn we define where our nav graph is for the fragment container view. And you can notice that we also add a bottom navigation view, which is going to be our buttons at the bottom of the screen. We can switch back and forth between the favorites fragment and the search fragment. So here's our fragment container view, and here's where we define the nav graph for the fragment container view. And that nav graph is defined in here. And it's in here that we tell the nav graph where all the fragments are, how to navigate between them, as well as what data can be passed between them. So for example, there's a fragment and there's an action. There's a navigation action to go from one place to the next. In this one here's an argument, search query in this example, which is a string that we're going to be passing from the search fragment through to the main fragment. And now that's about it for the very basic structure of the navigation. We can look at the page our app starts on, which is the search fragment. But before we do, actually, in the structure of our app itself, that we can see in the file structure there, we can see that each page consists of a layout file, a fragment, and a view model. So kind of similar in a way to the way we did the model view controller architecture in PHP in second year. In Android, we're using the model view model architecture, which is just the way that we separate our concerns. So for example, the model here in our model folder, we have a cocktail model, an ingredient model, cocktail response, and ingredient response models. And the reason we have these is to represent each type of data that we're dealing with. The response model for the ingredients in the cocktails, we don't really use them. They're just to account for the fact that our data is inside a list when it comes from the API. So there, for example, cocktail response takes, actually I'm not really using the ingredient response either, I'm using cocktail response. But they take a list of each type. So this is just to account for, in our API, all our data that we want to get at is inside a list. So that's where we're using our response object to wrap around the actual object. So that's our model. And our view is the fragment / the layout file. And then our view model that each fragment will have is the go-between to sit in between our UI layer and our model layer. We have that because we don't pass data directly between fragments, and we don't directly access data from our fragments. That's the job of the view model. So now that's the structure of the files done, so we can actually look at the starting page, which is the search fragment. And I know I said that they all have view models, but the search fragment is actually an exception. It doesn't need it because there's no data access in this fragment. All the work is done in the fragment. So the first thing to look at here is the binding. I'm actually using that on every page. I'll just explain it in this case. Binding is a very handy way that we're using to get a reference to our UI elements. If we didn't use view binding, we'd have to use find view by ID every time we wanted to refer to some aspect of the UI. So to do this, we've actually enabled view binding in our build.gradle file, which then generates binding classes for each of our fragments. Like for example, that search fragment binding will be a generated class that Android has made for us. So once we have these generated classes, we can refer to our UI elements in the layout files once we've inflated the layout and we've initialized our binding in each case. Like for example here, we use a latent variable for our binding to promise that we're going to initialize it, and then we actually initialize it inside the onCreateView method. So we assign a value and inflate our layout at the same time. So that's the binding, and then our actual search functionality is handled by these two methods. That's onQueryTextSubmit and onQueryTextChange. And we need both, even though the text submit is the only one that we really use. They work together. And then when the text is submitted, we pass our search query, which is this p0 to string, into our action view main. And then we can pass that on to the next page when we navigate. And one probably a bit different looking thing here is this safe navigate method. And this is just a helper method that I'm using to only navigate to the main fragment when it's safe to do so. And this prevents a crash whereby the main fragment isn't found. This was caused by an observer method on the main fragment. I'm using a media or live data. There was something strange going on whereby it would try to call the search again and navigate to the main fragment before the main fragment had been inflated. So this method fixes it. It means it won't navigate unless it's safe to do so. So now that's all for our search fragment. We can move on to our main fragment, which is in here. In the case of the main fragment, our favorites fragment and the detail fragment, on top of having the fragment, the view model, and the layout files, we have some additional files which facilitate our use of the recycler view component, the Android recycler view component. Specifically for each recycler view, we also have an adapter and a layout file for a list item. So in this case, for the cocktails list, the recycler view is tied to the main fragment, which is going to display our list of cocktails coming back from the API. For the favorites fragment, it's going to be a list of favorites in recycler view. And then within the detail page, we have another recycler view for displaying a list of ingredients. So the whole point then of the recycler view is to do what it sounds like. It recycles our views. We feed our data into the recycler view, and then it generates a list item for each of them based on the list item layout file that we've given it. And it's very efficient because when an item is scrolled down off the screen, the recycler view doesn't destroy that view. It actually recycles it by replacing the content of the new item that appears on screen when you scroll, but using the same view that has just gone off the screen. So that's the way it recycles them. So it's very efficient in that sense. And they all work in the same way. So I'll just explain it in the context of the cocktails list adapter, which is the first one we see. So we have our adapter itself, and then we have an inner class, which is this view holder. And the view holder and the adapter work together. The view holder wraps around the view in which we define the layout for each of our list items. Like for example down here when we bind the data, we call glide, which is an image plugin, and we say you can insert into the image view inside the view. You can insert this glide image with this URL, or you can pass the cocktail's str drink, which is its title, into the cocktail text. So that's how we're building the UI. We have three methods then, which is the onBind view holder, onCreate view holder, and the getItemCount. And the onBind view holder, we're going to call that when we're binding some data to a list item. So we're applying some data that we've passed into the recycler view into a specific list item. And then when we call onCreate view holder, we're actually going to make a new list item. And the getItemCount does what it sounds like. That just finds out how many items are in the list that we passed into the recycler view. We also have these methods now down the bottom, which are, these are interfaces. So we don't implement them there, just the very same as in Java. We define them there, but we don't implement them. We're going to implement them in the main fragment because the main fragment has access to the view model, which we're going to need if we want to click an item to pass you through to the next page, or we want to save or unsave an item. So that's all now, I think, for the cocktails list adapter. We'll go back into the main fragment, because that's all that's involved. So our main fragment here, we don't really have any other UI elements other than the recycler view. So the main job that the main fragment is doing is acting as a go-between for the recycler view's adapter and the main view model. Because as we said earlier, the UI layer doesn't deal directly with the data. For that we use an observer. So I have my observer here. Mine maybe looks a bit weird because I encountered a problem fairly early on when I realized that I want to be able to update the favorites, save or unsave a favorite sort of dynamically by clicking a little heart icon on the screen. So I needed to be able to observe both the data from our local SQLite database and the data coming from our API. So that's the reason that I'm using this live data, this merge data, I should say. We're watching our cocktail data and our favorites data at the same time. So we get all of our data in one go. And this wouldn't work if we were to try to have two different observers, or to have an observer nested inside another observer. I tried that. This is just the way you do it, using the media or live data, which is what this live data is. So we're watching the data coming in from both our API and the local SQLite database for our favorites. We then provide that data to a recycler view in there, pass it to our adapter. And then once all the data has been retrieved, well, then we pass it to the adapter. But this observer is constantly watching in this observer pattern. It's a live feed of the data from the view model. And then down the bottom, those interfaces that I was talking about, we actually implement them down here. So our on item click, we're implementing that from our cocktails list adapter, and in there we're just defining our action to pass in all of our cocktail information, then navigate to the next page. In the case of the on save click method, this is what controls saving and unsaving the cocktails, using the heart icon on the screen. And it does that by adding and removing from the local SQLite database that we have with Room, the Room plugin. We also add and remove from the view model's temporary list of cocktails, which then updates the data which the observer is watching. So favorite items, which is our reference that we have to our favorites list in here, we remove from there. From the view model itself, so actually from the database, we remove. And then finally, maybe very inefficiently, well, inefficiently definitely, I'm rebuilding the whole adapter every time that something is added or removed to or from the SQLite database. I'm sure it would make more sense to do one at a time if possible, but in our case we have so little data that there isn't really any noticeable impact on performance. It doesn't slow it down doing this. You don't even see it happen. So that's just the same thing then, depending on an if statement, where we have this if to check if the provided cocktail to this method already exists inside the favorite items, which again is like a local reference inside the fragment that we have to the actual database. So if it exists already and we click the heart, then remove it. Otherwise, add it to the list. And that's pretty much it, I think, for our main fragment. So we'll look at the other side of this fragment now, which is its main view model. And I'll go down first to the fetch data, because we were just looking at that in our observer there. So this is what we were observing in our main fragment. The fetch data method is of type media or live data, and it takes in this merge data, which is actually a sealed class that we've defined in here, which accepts both of these cocktail data and favorite data of type list cocktails and of type mutable list favorite entity. And this is mutable because you need to be able to add or remove from the list, obviously. But in that way we can just add these as sources. So there we're adding cocktails as a source, which we're getting from our API call. And we're adding favorites as a source, which we're getting from our local database. So once the data isn't null, you pass that in, and then we return both of these in one go. So that's the way that we can observe them all in one go if we want to. And then for each of these API calls, so that's where this one is coming from, for example, cocktails, so our list which gets filled by this method. So in here we're making an API call, same as most of the other API calls, with our search query passed in this case, to get cocktails in our retrofit instance. And this returns a type of cocktail response, which is where we have to get the drinks object from it. Remember we were saying that we have this cocktail response and the ingredient response. That's because our API returns a list. And we notice as well that we have this little icon here, which means that this is a coroutine. It's a suspended function. So we have this suspend keyword on the get cocktails. and we have this viewModelScope.launch, which means that this is running inside a coroutine. It suspends the UI, and we don't assign data in here the way we normally do. We instead use this post value, which means that we're posting data out from this coroutine back into the main thread. So that's it for our API call. We also have these save, remove, and get favorite methods, which are instead of the API, they're dealing with our local SQLite database. And we have it in a few places there, but you can see here, 98 and 99, we have temp favorites. And the reason that I have temp favorites is because favorites is live data, so we can't change that. And we need to be able to change the temp favorites whenever a favorite is added or removed from the list. So because we can't change favorites, I instead change the temp favorites, and then I just completely reassign the value of temp favorites to that favorites list. And then the get favorite and the remove favorite work in more or less the same way. And I know that was kind of skimming over some aspects of it, but I don't want to spend too long on it with unnecessary detail. So we'll move on now to the view fragment, which is the single cocktail page. So we actually have a lot of the same things in this file as we have in the other ones. One thing that's different is the fact that we aren't making an API call in here. Instead, we're getting our information from our arguments. And I haven't bothered to use parseable in this case. I just didn't really need it because all I'm passing through is strings, so I'm just passing them through separately. It works fine. But in the other case, on the different branch, I did use parseable because I'm passing through a map in the nav arguments, which needed to be parcelized for it to work. You can't pass a map in the nav arguments. But in this case, it's just text individually, so it's fine. Even in this case, we're using the Glide plugin again and passing in an image URL. One other thing that's different in here, I think it's 1, 3, 5, there you go. We're observing our current favorite. So we're checking to see if the cocktail that we're looking at the moment is a favorite which exists in the database already. If it is, then we're going to say saved on the text. Otherwise, we're going to say not saved. And that text is going to change then based on when you click the button. That's going to change dynamically. Another one here, which probably looks a bit strange, is my raw JSON parsing. And I'm parsing the JSON by hand because the structure of the API is not very good. They have about 15 empty slots on each of the cocktails for the ingredients and measures, despite each cocktail only really having about 3 ingredients. So I really didn't want to have 15 null properties on each of the cocktail objects. So instead I've added a map into the cocktail class. See that? Ingredients is a mutable map, 2 strings. I've added that map, and then I'm iterating over that raw JSON and taking out the ingredients and the measures. I'm adding them into that map that we have here. And then we pass that through into our adapter. Now the map that I showed there on the cocktails, I'm not actually using that in this case. I'm using that on the other branch. On the other branch, I am actually adding that into the cocktail object itself. In this case, I'm just passing the map into the cocktails list adapter. So that's how we get our ingredients. And then we pass that into our recycler view again, same as we do on our main fragment. So then we can display a list of all our ingredients, the same as we do with the cocktails themselves. And we've added a list or click listeners to each list item there. So you can actually then click on an ingredient to get more information about it if you want. So moving down then, we have a custom font on this page. It's nice. We have this different save and return function, which again probably looks a bit strange. I'm doing it this way because a problem arose whereby the app didn't navigate back to the right page properly. And that's because we can get to this view fragment from both the favorites fragment and the main fragment. You know, you can view a cocktail from the favorites page, or you can view a cocktail from the main cocktails page. So I've had to add this fragment name into the nav args, so you can pass in a fragment name. And in this case, If we pass main fragment as a fragment name, then the button is going to bring us back to the main page. Otherwise, it'll bring us to the favorites page. I'm doing this way because I thought it was just more efficient to have one detail page between the two of them rather than having a favorites detail page and a main fragment detail page, which are the same page. So even though it looks probably a bit stupid having to animate them all manually, doing it this way, I think it's probably more efficient in a sense. We have our save favorite method, which works the same way. It's saving and removing from the local database, same as it does in the main fragment, except we're not having to update the recycler view in this case because we're looking at a single cocktail. We don't have to update the list. So that's probably all that we need on this page. We also have this on item clicked actually method. In here we're actually observing the ingredient details because we call the ingredient details on this page when we get here. So it's going to be populated now. So when we come into the view fragment, then we call this ingredient details API call. So then down here we can observe it. So we're just looking to see if this cocktail that we're looking at, or this ingredient that we're looking at, has a description. And if it has a description, then we'll pass you through to the next page so you can read the description. And if there isn't, then we just won't assign a click listener. You can only click on an ingredient that has a description, which is intentional, if some of them don't. The difference then on the other branch then is that I have a visual indicator to show which ones you can click on and which ones you can't. So we'll see that when we do the demonstration. So I think that's probably enough. I have the view model for this as well, but it's more or less the same. There isn't really anything new to show off in there, so I won't demonstrate that. In the favorites fragment then, again, there isn't anything too different from the other pages in here. We have an observer which keeps an eye on our favorites data, which is coming from our local database instead of from an API again. So our observer here watches our favorites list, which we then pass into our adapter, and we populate our UI with that. So we have a list of our favorites here, and we have a remove method down here, which again works more or less the same way as the add and remove in the main fragment, except we're not going to be adding stuff to the database in here. We're only going to be removing. You're not going to be on the favorites page and adding favorites. You're already looking at your list of favorites, so all you're going to do is remove them. And in this case, we have this notify item remove method and this remove view at position. So that's just removing it from the UI. And it works very nicely because Android applies a smooth animation to it when it gets pulled off the list. And then the list will update using this notify item removed. It'll update the indexes to account for the fact that one of them is gone. Our favorite items, again, we're updating our local reference to the list, and then we're removing from our actual list, the actual SQLite database. We have this little check then down here just to say if there are no favorites, as in if we've just removed the last favorite from the list, then show a piece of text to say there are no favorites. This will also be shown if there's ever an error, or if there's not even necessarily an error. If we come to the favorites fragment and there are no favorites, then it'll show this message to say there are no favorites. And there as well, we actually have that on the main fragment as well, is a spinner. We initialize the spinner there, and that's set to visible by default. When our data loads in, if it all loads in fine, then we'll hide the spinner. Or if something goes wrong, or if there's no favorites otherwise, then we'll hide the spinner. So we'll get a little loading indicator to say that our stuff is getting loaded in. And I think that's probably enough for our code explanation for this. So I'll demonstrate the app now instead. And I realize I probably skimmed over some aspects of this, but I didn't want to spend too long on it and go into unnecessary detail, as I say. I think my comments probably do explain in more detail anything that needs more explanation. There'll probably also be features that will be visible now when we do the demonstration. So here's our app. This is the search page. We can go back and forth between our favorites and our search. There's vodka, search for something. There's our list. You can see our bottom navigation bar disappears when we scroll. Search for something else. There's rum. It's a much longer list. If we go back to say vodka, you can click this, view its details. There's a custom font. There's our images loaded in with Glide. Here's our nested recycler view we're populating with our raw JSON. Go back out of Vodka. You can save it from in here. If you go back out, the heart changes color. Go back in, unsave. Heart changes color again. I can save in here, and it works the opposite way. It's now saved. I can unsave from there. It's now unsaved. I can do that in any order I want. There's 3 long vodka, coffee vodka, vodka Russian. They now appear in the cocktails list, our favorites list. I can unfavorite them, whatever order, doesn't matter. Go in and view details from the favorites page, that's fine. I can unsave them from here, that's fine. I can remove the last one, no issue. Go back to our search page. Allowed loads of stuff in whatever order you want, no issue. And I say no issue because there were bugs relating to this that I've since fixed. This was fairly awkward to get working. Whatever combination you want works fine. Add and remove in whatever way you please. So I don't think we have anything more to demonstrate there. That's the main branch done. So as I say, I just have one more small feature to demonstrate on the other branch, which I'll switch to now. So I'll just pause the recording and switch over. So here now in our other branch, the one difference that we have is that we have these visual indicators to show which ones can be clicked on. As I was saying, some of these ingredients don't have descriptions. So in that case, you're not going to be able to click on them. Whereas on the other branch, you just can't click. That's it. There's no indication of which ones can be clicked and which ones can't. Which is intentional. If it doesn't have a description, I don't want you to be able to click on. But here I have an indicator to say you can click on this. If I try and click on Lightroom, that's fine because our indicator says it has a description. If it doesn't have an indicator, that means you can't click. And it seems to work fine there on Roam. The reason that I didn't merge it is because it doesn't seem to be very stable. For example, if I go to Vodka, that seems to work okay actually. Obviously you can't click trips, you can click Vodka. But it just doesn't always work as you'd expect it to. It doesn't always seem to display the right ingredients on this branch, and it seems to also duplicate some of the cocktails on the main fragment. So it does kind of work, but I just didn't want to merge it because it obviously isn't very stable. So I think now that's probably enough for the demonstration of both branches. Hopefully I've covered everything in enough detail and not in too much detail either. As I say, there are comments in there explaining some things maybe in more detail than I've given in this video, if they need it in some cases. So that's been my video presentation for the Mobile Development CA. Thank you.